club flies, generally we are sticking to one-day launches right now due to our time constraints. It takes a lot of time and effort to run a launch. But our window for our waiver runs 10 a.m. to 5 p.m. Just call the airport and activate it depending where we are, but we'll call O'Hare or Metro. And also we call the local airports just as a courtesy note. Then it starts setting up the equipment. We generally get there a minimum of 2 hours early. There's a lot of equipment to set up. Our personal club has the ability to launch 20 pads. So we can set up 20 different rockets at once and then fire them off one at a time. Or in some cases do what's called a drag race and launch 2 rockets at the same time to see which design might be faster or which motor outperforms that motor.
Born again Rocketeer. I got back into it about 1995 and have been doing it ever since, and our club has just taken off and grown.
Got involved when I was a kid, and typical born again Rocketeer, I let it go for about 15, 20 years when I discovered girls, cars, those other demands for the wallet.
I started when I was a kid, maybe 11, 12 years old. Got a kit for my birthday, and my dad and I put it together and started flying. Just little stuff. And then about 5 years ago I started up again in these bigger rockets, the higher power rockets.
3, 2, 1.
Generally, the rocket will have a nose cone on the top and the motor will be on the bottom inside it. And we always use an electrical ignition to light it, so we use an electrical source, and there's a safe distance that you have to be away depending on the size of the motor. Obviously, the larger the motor it is, the further away you need to be. So we use this electrical source, and it's going to light a chemical on the top. It's going to just flash briefly. That chemical will be inside the motor, inside the nozzle, touching the propellant. So when that lights, the propellant's going to light and it's going to turn the solid propellant into a gas. And since gas takes up more space than solid, it's expanding and it's going to be forced out of the nozzle. As it's forced out of the nozzle, your rocket's going to be pointed upward. The gas is going to be forced down at extremely high rates, in fact breaking the sound barrier. And so the opposite is going to happen, the rocket's going to go straight upward. Now, when the rocket runs out of propellant, the motor's all done, it's going to reach what we call the coast and tracking phase, or it's going to hit that delay element that looks a lot like a smoke bomb. It's just going to pour smoke out of the end of the rocket. And since the rocket was just going extremely fast and we ran out of thrust, it's not going to stop instantly. It's going to start slowing down. When it starts slowing down, it'll pitch over. And about that time, we're hoping our delay element is completely run out. and it's going to hit an ejection charge, or it's going to hit the black powder, similar to what you use in a muzzle loader or an old style gun. And the black powder is going to force a lot of gas, and it's going to build up pressure in here, and it's going to pop out the nose cone. Now, inside this nose cone, or the nose cone is going to be tethered together. It's going to be tethered to the body tube and itself, and it'll have a parachute attached, or whatever type of recovery device you're using. Parachute, again, being the most common. Parachute will generally be attached to the shock cord, and we want it to slow the rocket down just enough so it'll come down as quickly, but again, it's going to be slow enough so it's not going to hurt itself or anybody else upon landing. Because the whole object of rocketry is safety is the #1 priority, and then doing it successfully is the second priority.
Rocketry is a wonderful tool for hands-on experience in math and science, and I guess the biggest thing I like about any of the building that I do, either with myself or with the club or with my kids, is the problem solving.
This is in particular is an F class motor. F describes the total impulse, starting with A, and they go all the way up to O. And each letter increase doubles the total energy or work that the motor has.
Rocket science is definitely used in the larger rockets. Even the materials that are used are very much alike what NASA would use on the space shuttle. And the solid booster motors that you might see here on some of the rockets today, the components in which those engines are built are very similar to the solid boosters on the shuttle. So indeed we get to participate on a small scale like NASA, but it's not nearly as formal.
Some people are interested in gaining severe altitude. Some people are interested in actually photography or other instrument work at higher altitudes. Other people just like to build designs that'll be real slow flying but extremely stable. Every rocket has to be RSO'd, where it's called a range safety officer. It's a person designated to look at every rocket to make sure it's in flyable condition, it's got an adequate motor, so it's going to achieve a stable flight before it can even be put on the launch pad. We've got what's called an LCO, or a launch control officer, where that's the only person that will be launching the rocket. They're physically pushing the button to launch it. We do this so there's less confusion. Someone doesn't accidentally launch a rocket while another person is out on the pad loading them. And again, it's just another safety precaution.
That thing sounds like a sonic boom.
In the times of today, a lot of people are misunderstanding what rocketry is. In the last year, terrorism has really been a big subject of topic of conversation. And rocketry, or any types of things that people think are explosives, they're wanting to abolish that and get rid of it. Well, rocketry is far from that. The propellants that we use are in the solid motors for the high power stuff. It can be dangerous if treated without respect, and if not properly handled.
All the propellant we use burns, and it burns fast, but it does not explode. If something should ever overpressurize, all these motors are designed to split apart and actually extinguish the propellant so nothing will burn, and when it fails in a very safe manner.
The biggest thing is respect. It's taking care of the people around you, keeping them out of harm's way. Safety is an utmost concern that we have, and it's very, very important, and we stress on that. Even though we have a relaxed environment, we're keeping our eyes out for aircraft that are in the area, but also people off the range when the range is closed. Very important, and we stress on that. So we try to have a fun but yet safe environment for everyone, even the spectators that come out. So we pride ourselves on that.
I got the rail. You guys keep the rock. No, for your.
Okay, well, I saw that one closed and I thought. Tell me where. Where are we going?
Cut it. We're not sealed.
Everybody ready?
Yep.
Yeah.
Ready?
Cameras ready? Yep. Okay. Fill, arm, go.
Upside. About 20 seconds.
Setting.
Yeah, got it.
All right. Clear for fire. 5, 4, 3, 2, 1. Ignition.
Wow.
Hey, Joe.
The fellowship and the camaraderie is awesome. That's probably one of my most favorite things.
It's a hobby like no other. If you get into racing, whether it's RC cars or etc., people make these fine-tuned adjustments on their car and they don't want anyone else to know about it. They want to have the edge on the competition. Where in this, if someone comes up with a new style in rocketry and it works for them, they're going to let everyone know. I mean, it's kind of like a bragging right. I came up with this works so well, give it a try. And it's an experience that everyone should feel at least once in their life, and I'm just glad I'm a part of it.
Level 1 is you fly a rocket on an H or an I motor, and it has to land in good enough condition to be flown again that same day. Level 2 requires a written test on safety and on actual knowledge of rocket motors, aerodynamics, and then you fly a rocket and get it back. And level 3 is actually you go through there's an advisory board that approves your project, make sure that it's safe, and then you build it, fly it, get it back, and fly it again.
I've achieved all 3 levels of certification for my rocketry license, which after mid-power rocketry, there breaks it up into 3 levels. The H and I motors would be considered level 1, J, K, and L motors would be considered level 2, and M, N, and O impulse motors would be considered level 3. Anything larger than an O would be classified as experimental rocketry. It's one area I haven't gotten into yet, but well, hopefully I will eventually. I have successfully flown a few M's and do see more in the future. Now, when you get into the M's, the weight of the rocket is drastically increased. In fact, you're usually in the 50+ pounds for a rocket, and you have to use electronic devices, and that's where the complexity goes up severely. I've never seen the end in sight. You know, there's so many things I have not personally accomplished in this hobby, and well, hopefully I'll never say I have, because I don't think I ever want to get out.
3, 2, 1.